And now, the analysis procedure.
Open Mac1 Analysis and open the folder path containing the result files. Now we will analyze the polyethylene sample. Click on the result file and select the move relative function. Choose the force in the z direction for the vertical axis and position z as a horizontal axis. Now from the Analysis drop-down menu list, select Slope. Move the cursors to select the first linear portion of the curve, which corresponds to the elastic region of the curve. The elastic region of the curve corresponds to the region where a material deformed under load will return to its original shape when the load is released. Now if you want to have a better look at the load displacement curve, you can zoom in to ensure that you selected the linear portion of the curve. In this case, you report the slope as the stiffness of the sample. Now let's analyze the skin sample, which corresponds to a rat skin. Select the move relative function and we will zoom in the curve in order to select the first linear region of the curve. You can even zoom in more. There you go. So you report the slope as the stiffness of the rat skin.
The slope obtained from the analysis corresponds to the tensile stiffness of the sample. In order to obtain intrinsic mechanical properties resulting from the tensile test, the sample's shape and dimensions need to be considered. Use the following equation involving the slope, the sample's length, and the sample's area to obtain the Young's modulus. Using the parameters of the sample, such as the width, the thickness, and the length, calculate the stress and strain from the load displacement data. Let's consider the data from the tensile test of the polyethylene sample. The width being 3 millimeters, the initial length being 28.3 millimeters, and the thickness being 40 micrometers. Here is the stress-strain curve of the polyethylene sample. And now, the data from the tensile test of the rat skin sample. The width being 3 millimeters, the initial length being 28.3 millimeters, and the thickness being 1.4 millimeters. Here is the stress-strain curve of the rat skin sample. The ultimate tensile strength and the elongation at rupture can be obtained from those curves.